Alright, Algebra 2. Today, this week, we're going to keep on focusing on even and odd and neither functions. Just being able to recognize them. Because I think it's something that we should be able to do. It's a college algebra type lesson when you're talking about just the basics of functions and how they behave. At any rate, we'll look at a couple examples and why are they even? Why are they odd? What makes them that way? So let's look at something really simple. I'm actually going to draw up a graph. Not that small, but so let's just say we have an XY axis and we have the line y equals x. Let's say that that's a function. Let's put this in function notation since we're talking about functions. Why is f of x equals x odd? Okay. Now let's just draw up some points here. Okay, here's my y-axis, here's my x-axis. When x is 0, y is 0. If you don't get where I'm getting at, remember your table of values. Okay, let's put x here and f of x here. Let's just put in a table of values. It won't hurt. So I'm going to put 0 right here. If I plug 0 in for x, well, that is 0. If I plug -1 in for x, it equals -1. It is what it is. F of x is x. So if I plug 1, it's 1. If I plug 2, it's 2. If I plug 3, it's 3. If I plug -2, it's 2. -2, sorry. So you got all these points. And I want to plot them. There's -1, 1, -1. There's 0, 0. There's 1, 1. 2, 2. 3, 3. And then -2, -2. So there's kind of like, well, there is my line, okay? There is my line. And it is an odd function, okay? Because if it does a rotation about the origin, 180 degrees, let's take this portion right here. I better use a better color than that. Let me use purple here. If I take this end and I rotate it exactly 180 degrees, a half a circle around the origin. Now here's your origin. Okay. I produce the exact same thing. And that's with respect to the y-axis. Another way of looking at it is when you plug in algebraically. Okay, let's get algebraically here. If I plug in that -x, what does that give me? -x. Okay, so if I focus in on this point here, if I plug in 1 into x, I get 1. If I do the exact opposite, if I plug in that negative opposite of x, what's the opposite of 1? -1. If I use that as my input, okay, if I use that as my input, that's going to give me -1, not -11, -1. So that's literally the exact opposite of this point. Okay? therein lies the 180-degree rotation. So if you're looking at it graphically, with respect to y, okay, it's easy to figure that part out. Okay, I want to quote a book here that I have. The graph of an odd function in which f of negative x equals negative f of x is symmetric with respect to really the origin. It says the y-axis, but really it is the origin. Okay? It's symmetric. You could actually cut it a line this way. Okay? And there's that symmetry. It's going the exact opposite direction. Alright? Now let's, I think graphically is easy. I think the more difficult one is when you're given an actual function and you don't have the graph. You can punch it in on a graphic calculator. I think that's something Mr. Teeters said that he told you could do, and you know what? That's a brilliant idea, actually. And you can just look at it graphically. Algebraically, let's just look at a couple of them. Let's check this, see if it's even, odd, or neither. Okay, so alright, so that's what we have. All I'm going to do is replace x with negative x. And I like to put 1 there. So I got negative 1x cubed minus 6 times negative 1x. Now, if I get the exact same thing, what does that mean? What that means is graphically, it is a perfect reflection along the y-axis, and the signs do not change from the original function. That's why I like to stack these two on top of each other to see if the signs change. Now, if I plug negative 1 to the third into the calculator with parentheses, that's how you do it correctly, I get negative 1. X raised to the third is x to the third. Well, right off the bat, I know something changed. So if I had the question, is it even, odd, or neither? Well, right off the bat, I'm going to say, well, it's not even. I need to check every term, though. I just can't say, oh, the first one changed, it's odd. No. Okay, I need to check them all. So, negative 6 times negative 1, well, that's positive 6. Well, that's the exact opposite of this guy right here. So, in every term in the original function, the signs flipped. If every sign flips, then I can say, yeah, it's odd. Okay? It is definitely an odd function. Alright? Algebraically, I think algebraically is a college algebra thing. It has to be. You got to be able to do it. So let's look at this next example. Let's call it g of x, just to be different. There's only so many f of x's that I can handle. Let's go x to the fourth minus 2x squared. I'm doing some simple ones, but it's the same process. I'm just replacing x with, let me use different colors here to get your attention. I want to replace x with negative x. And I want to go beyond that and call it negative 1x. I would like to see that number. Okay? So everything that is x becomes negative 1x. Exponents are kind of lingering outside the parentheses. Now, the day-old question is it even? Oh man, I can't get the E. Odd or neither? Woo, my stylus is getting wore out here. Well, let's do it. All right, let's see what happens here. Let's see if that first sign changes. -1 to the fourth. Use the parentheses in the calculator. -1 to the fourth power is 1. That's x to the fourth. Well, guess what happened? The sign stayed the same. They're both positive. That's all you're really doing. You're just checking to see if the sign changes. Okay, in this case it didn't. Now over here, it's going to be a little bit confusing because I need to do the exponent on -1x first. I need to square it. -1 squared in parentheses -1 and then outside parentheses square. That gives me +1. So I need to do a little bit more work. I know this sign didn't change. Woo! I just really messed this. Let me see if I can scoot this over, guys. There we go. I really goofed up there, didn't I? Alright, so I need to, I've already checked this, and that sign stayed the same. Let's check the -2 and 1x squared. Okay, actually, that square could go here. -2 times 1x squared is -2x squared. Well, guess what? This sign and this sign also stayed the same. Well, if they both stayed the same, it's definitely even. Alright. Algebraically is where it's at, if you really want my opinion. Okay, last example here. I ain't going to bore you to death because you got a lot of problems. Let's go to h of x. Okay, day old question, even, odd, or neither. Alright, sloppy with this thing. Alright, so h of x equals, let's do a quadratic equation here. X squared plus 2x plus 1. Alright. Well, if we plug in, like I said, -1x, then, for every x that I see, we're going to check to see if we have any sign changes. If we do, we know it's not even. That's the big thing. I always think even first. Okay? And it may be neither. Okay? That's why it's important to check them all. Now, this constant term, it's staying the same. There's nothing that's going to change its sign. So, to me, I could automatically, since that stayed the same there, the +1, I know it's not odd. Okay, it could be even or neither. Well, let's check. -1 squared is 1. X to be squared is x squared. Distribute -2x. Okay, now, this stayed the same, but that changed. Even if only one thing changes, if one sign changes, okay, that changes everything. It's a neither function. Alright. Well, guys, I will continue Wednesday with this. And hopefully you guys are getting good at them. Alright. So, get working, and I will, video-wise, I'll talk to you Wednesday.